Okay, I brought the problem in we discussed during the help session today on navigation that I was asked about. So let me just read it so you can, and I may not be able to read it super well. It says a plane flies 810 miles from Franklin to Centerville with a bearing of 75 degrees, clockwise from north, it tells you. Then it flies 648 miles from Centerville to Rosemont with a bearing of 32 degrees. Draw a sketch that would visually represent the problem, and then find the straight line distance and bearing from Rosemont to Franklin. Okay, so let's look and see what we do. First, we're going to draw a sketch. Okay, just filling in all the information that's given. So now, a couple things I want to point out. So notice I draw a coordinate axis whenever I'm starting to draw an angle. And notice it said 75-degree bearing, and it's a navigation problem, so you measure from due north. So here's our 75 degrees. So it's from due north down to this line right here. Okay, so this is showing the path from Franklin to Centerville. All right, now once the plane reaches Centerville, then it changes directions, changes course. So what we do is draw a coordinate axis right at the end of that first segment, and draw another coordinate axis and measure from due north again, and this time it's 32 degrees. So we're going to go from here to here. Okay? So that's all we need to do so far. So the first leg was 810 miles. The second leg is 648 miles. So those are labeled. We are going to want to find C because that would give us the straight line distance from Rosemont to Franklin. Rosemont to Franklin. Okay, so that's the setup so far. Now notice I said 90 minus 75. Okay, so what that's showing is I want to know what this little angle is right here. I'm trying to get it to point right to where I'm saying. Right there, because I know that all the way down to here is 75, but I want to know what this little angle is, and you'll see why in a moment. So it's 15 degrees. Now, let me just pause it for a moment and point out that notice that this right here is 15 degrees, and so is this. So this is one reason why we draw the coordinate axes at the end. It gives you some parallel lines. So this is a horizontal line, and so is this. This x-axis and this x-axis are parallel because they're both horizontal. And so now this is our transversal. So you see that we have a transversal intersecting two parallel lines, so alternate interior angles are congruent. So this one and this one are congruent. So that's the way that you get your angles inside your triangle, is using things like that. Okay, and then of course this angle right here is 90 degrees. So now we can add 32, 90, and 15 to get what angle C is altogether. So that's 137 degrees. Now we can use law of cosines to help us find that length for C. Okay, so see how the coordinate axes, they help you draw your bearing, but they also help you use alternate interior angles to get angles that are missing. So I'm going to push play now. I'm just recording my earlier work. And I'm just reminding you that alternate angles are congruent when the transversals intersecting parallel lines. So we're going to use law of cosines to find lowercase c, which is right here. And I didn't show step by step. I just went right to my calculator and wrote down this value. And then I took the square root of that answer, and I got 1,357.8 miles. So that's the length of C. That's the distance from Rosemont to Franklin. Okay? Okay, so we've answered the one part, the straight line distance, but now we need the bearing. So if we want the bearing from R, Rosemont, to Franklin, we want to measure, we need to know what the angle is from due north all the way around to here. I don't know if this is, my arrow is staying with me well enough, but you want all the way down to here, this line. So you're going to see that in just a moment. So we do get a bearing of 236 degrees, but let me show you how we do that. So we use law of sines to find angle y. Sine of y, and that's this angle down here. Sine of y over 648 equals sine of 137 degrees over 1357.8, which was side C. And we find that y is equal to 19 degrees approximately. So if this is 19 degrees, we're going to use alternate interior angles once again well, actually, a couple things. Let me just push play and then I'll explain. Okay, let's pause it right there. So what you can see is if this is 75 degrees down to here, what we did was subtract that 75 minus 19 degrees to get our 56 degrees. So I did that right here somewhere, right here. This work. Okay, so now we do have alternate interior angles again. I kind of jumped ahead of myself, but so here from this vertical side is going to be parallel to this vertical length right there, the y-axis. So the y-axis here is parallel to the y-axis here. So if this angle is 56, this angle is also from the vertical to the slanted line. Okay, now the reason we needed to find that is we needed a bearing, and we needed to start at due north and come all the way around to this segment in a clockwise direction. So I have the blue arrow showing that 236. So that is simply, it's going to be 270, well actually 180 plus the 56 is what you would do. Okay, so I think I have that shown. Yep, and so I was thinking we could go up to 270, but we don't know what this little angle is here. So what we do instead is say, well, we'll come around here and say 180 down to here, and then add the 56 degrees. So that's why we need to find that. And so now we would say, because we measured that from due north, we would say that the straight line distance is 1,357.8 miles at a bearing of 236 degrees, which means you measure from due north and you came all the way around to here. Okay? And that is how you do this problem, and this is why it was quite involved, so that's why I wanted to wait and not do it during our session. So just email me if you have questions about what I did, and I hope this helps.